All right. Today we are given a problem like this. This is a simultaneous equation, all right, of two variables. We are asked to use Cramer's rule to solve this. Now, for all simultaneous equations, we can use the method of elimination or Big's equation to be able to solve. But in this case, we are told that we should use Cramer's rule. This is understanding of Cramer's rule is very important. And then there is no way you will talk about Cramer's rule that you will not make reference to determinant in a matrix, all right, or metrical determinant. So we have this equation and we want to solve it. Solution, all right, so we bring down the equation. Now, when you bring it out like this, to be able to write this equation in the form of matrix, all right, we know that this x, there is 1 hiding here. All right, the coefficient of x here is 1. The coefficient of y here is 1. Of course, in that order, -3 is coefficient of y, and then we have 1 as a neutral number. Then the coefficient of x here is 2, right? For y here is 1, and then we have 23 as a neutral something. So this 1 and 2 are coefficients of x in the two equations. And then this 3 minus 3, all right, minus 3. Okay, this is supposed to be minus 3. Okay, let's have it as this. Minus 3 and plus 1 coefficients of x. Then we have, these ones are neutral coefficient because they do not have or possess any variable. So if I want to write this in terms of matrix, I will now say let matrix A be equal to, or we can rewrite this. So the matrix equation, all right, let us write the matrix equations will look like this. 1 minus 3, 2, 1. All of this multiplying x and y equals 1, then we have 23. All right, this is the matrix equation for this. If you open the bracket, you're going to come back to these two equations. All right, when you have written it in terms of matrix like this, all right, then we now say let A be equal to 1 minus 3, 2, 1. Right? This is the matrix. Okay? So the Cramer's equation. The Cramer's equation states that if we want to get our x, then the determinant of x divided by the general determinant, and then for y, you have the reference determinant of y divided by the general determinant. Now, how do we get this? So for 2 by 2 matrix, the determinant, this is how to write determinant of a matrix. Determinant of A is equal to the determinant of the value of A, which is like this. So if you have 2 by 2 matrix, you multiply the diagonal and find the difference. So here, you multiply this diagonal and then multiply this diagonal and then find the difference. So to multiply the diagonal, we have 1 multiplied by 1, that is this 1 times this, then minus finding the difference. Then you have 2 multiplying minus 3. So if you work this, it means that the general determinant, which is equal to the determinant of A, all right, the result now is going to give us 1 plus 6. That's going to produce 7. So we've got the general determinant of this matrix equation. So to be able to get that of reference determinant of x, what we do is in this arrangement, if you're going to get with respect to x, all right, what you do is you exterminate the coefficients of x and bring in the neutral coefficient. So for x, the first one, this neutral coefficient will take the place of x coefficients, and then you bring down the coefficient of y. So this one is saying that you are finding the determinant of x, right? So when you do like this again, we are going to multiply the diagonals, which is 1 times 1, okay? You have 1 times 1, minus, then you have minus 3 times 23. So what you have plus 13, plus 69. This is going to be plus 69. And the result is equal to 70. So finally, we go to that of y. So we bring down the coefficient of x, and then we exterminate the coefficient of y, and then bring in neutral coefficient. That's going to be 1, then 23. Of course, what we have here is you still do the same. It's going to be 1 multiplied by 23 minus 2 multiplied by 1. Now, if you get used to it, it will not be a headache, all right? Trying to find the difference of the multiplication of the different diagonals, all right? So you understudy it very well patiently, and then you get used to the trend. So if you do that, the result is going to be, you have 23, then minus 2. That's going to give us 21. All right? So our x, which is defined as delta x over delta, will be equal to, so the value of delta x is 70 over the value of delta is 7. So you bring it like that, and the result is equal to 10. Therefore, our x is equal to 10. And then if we want to get our y is equal to delta y over delta, and then our delta y is 21. So you have 21 over 7. The result is equal to 3. That is, our x is 10 and our y is equal to 3. Now, you have to watch out, because in our next lecture, we are going to be solving, using Cramer's rule, right, 3 simultaneous equations, which is what we commonly call triple equations of 3 different variables. It will take a little bit different trend compared with what we have just solved now. So watch out for our next lecture. If you have actually understood what we discussed with respect to Cramer's rule, I want you to try. I want to find out your understanding. There are 2 equations here that I want you to try as assignment. The first question says 2x plus y equals 2 and x minus y equals 13. You are to use Cramer's rule to solve this problem. The next problem is 3x plus 2y equals 4 and 4x minus 3y equals minus 23. So please, I want you to solve these two questions using Cramer's rule, and then post your results on our platform.